All right, this video is on adding and subtracting fractions. So here's an example. We got 4/9 plus 2/9. So the first thing you want to look at is the denominator. Remember, the denominator is the bottom numbers. And that number needs to be the same. So we're good in this case. They're both 9. So if they're the same, you can go ahead and add. So remember, when you add, you're only adding up the numerators. So I'm going to do 4 plus 2 is 6. Don't add the denominators. The denominator stays the same as 9. So only add or subtract, depending on what you're doing, numerator, and then the denominator stays the same. That's a common mistake people make, more with adding, because subtracting you kind of realize you'd get 0, but with adding, people like to add that up accidentally, and that's not correct. So denominator stays the same. That's why you're getting a common denominator, to figure out what would they be together in that denominator. The only other step other than that is to then simplify your answer. So we have 6/9. Both 6 and 9 are divisible by 3. So I'll divide them both by 3, and I get 2/3. So that's my final answer when I add 4/9 plus 2/9. Subtracting, exact same thing. First, we look at the denominators, make sure they're the same. In this case, they are, so I don't need to do anything. And then same thing, I just subtract the numerator. So 5 minus 1 is 4. Keep the denominator the same. So subtract numerator. Denominator stays the same. The last step is make sure there's nothing you can simplify it by. In this case, there is. We can simplify it by 4, divide them both by 4, and you get 1/3 as your final answer. So 5/12 minus 1/12 is 1/3. So I want you to go ahead and pause it, practice these two on your own, and then hit play to check your work. All right, so both of these already have common denominators, so I don't have to worry about doing that. So all I have to do is subtract the numerators. 3 minus 1 is 2/8, keep the same denominator. And then they can both be divided by 2, so I get 1/4 as my final answer. Next one, again, common denominator, so I just add up the 5 plus 5 is 10/6, because it's still common denominator. Simplify, if I divide them both by 2, I get 5/3. It is fine to leave it improper like that, but if you want to turn it into the mixed number, or if you did turn it into the mixed number, it would be 1 2/3. So either of these answers is fine. They are both simplified, so they're both acceptable. All right, so what do you do when you look at this and you notice this time our denominator is not the same? We got 9 and we have 3. So we need to get those denominators to be the same. So what you're looking for is a multiple, some number both of those denominators can multiply to get into. This one's fairly obvious because 3 is pretty easy to turn into 9. If I multiply 3 by 3, it becomes 9, okay? So remember, I can't just multiply the denominator, you also have to multiply the numerator. So 2/3 is going to turn into 6/9. It's equivalent to 2/3, but now it's in ninths. And 4/9 I'm going to keep the same. Okay, so our first step, make sure you have the common denominator. If you don't, you got to use equivalent fractions like this, where you're multiplying the numerator and denominator to get a common denominator. At this point, I can just add up my numerators, which is 10. I keep 9 in the denominator, and that's my answer. It's simplified, but if you want to make it a mixed number, that's fine. So either of these answers is fine, okay? So remember, you need a common denominator. If you don't have a common denominator, meaning the denominator is the same, you need to make it the same, okay? That might mean only changing one of the fractions like we did here, or you might have to change both of the fractions, okay? So common denominator, and then you keep that denominator. Your final answer has that same denominator. Keep the denominator for the answer. Same thing here for subtractions. We got 12 and we have 8. So this time I'm going to have to change both of them because I can't multiply 8 to get 12. So I'm going to have to change both of them. So I start thinking, okay, what are some multiples of the two of them? One thing you can do is just do LCM if you want. You can do LCM over on the side. I remember how we do the little ladder. And when I get to this point, I multiply all these together and I get 24. So 24 is my lowest common denominator, because lowest common denominator is the same thing as lowest common multiple of the denominators. So that's one way to do it. If you can't immediately tell what to do, just do LCM and that will take you right to the lowest common denominator that you can use. So I have to think about, all right, what did 12 have to be multiplied to get to 24? 2, so I'm multiplying these two by 2, so that becomes 10 24ths. And then 8, it had to be multiplied by 3 to get to 24. So I multiply the numerator and denominator by 3, and I get 3 24ths. So 5 12ths is now 10 24ths, 1/8 is now 3 24ths. They're equivalent to their original fractions. Don't forget we're subtracting. Subtract the numerators, I get 7. And then denominator stays the same, and I get 7 24ths. I double check there's nothing I can simplify by, there's not, so that's my answer, okay? So remember that common denominator, it's really important. If you don't do it, you're gonna get the wrong answer. All right, so here's our steps if you're someone who likes to think about it in step by step. 1, we need a common denominator. If there's not a common denominator, then you do need to do the multiplying to make equivalent fractions that do have common denominators. Next step, add or subtract whatever's in the numerators, then keep the same denominator, and then finally you simplify to get your final answer. All right, so both of these are examples where you'll need to find a common denominator. I want you to pause it, find that denominator, and then go ahead and do it out and hit play to see what your answer is. All right, this first one, 5 and 8. So my only common denominator I can do at this point is multiplying the numbers together. So it would end up being 40, right? 5 times 8, 8 times 5, they're both 40. So you can always do that. It's worth looking to see if there's one you can do that's lower than just multiplying them together, because sometimes that ends up being a pretty big number. But at the very least, you can always multiply them together like that. So I have 24 40ths, and I have 5 40ths. I subtract 24 minus 5 is 19, still 40. So 19 40ths is that one. This one here, 9 and 6, their common denominator, the lowest one you could do is 18. Okay, so that's an example where you don't necessarily want to just multiply them together and get 54, because that ends up being pretty big. And remember, you can always do a little LCM over here if you're not sure what to do. If I multiply 3 times 3 times 2, I see I get 18, okay? So the 9 had to be multiplied by 2, so that makes my numerator 10, plus this time it had to be multiplied by 3 to get 18, so that makes this numerator 15. So now I add it up, I get 25 18ths, and that's actually simplified. If you are one of those people who likes turning it into a mixed number, you can. That would be 1 and 7/18. So either of these are acceptable and correct. All right, so let's practice this with some word problems. So Ms. Cross said that if it snowed over 1 inch in a week, she would give us Friday off. On Monday, it snowed 1/10 of an inch. On Tuesday, it snowed 1/4 of an inch. On Wednesday, it snowed 2/5 of an inch. On Thursday, it snowed 3/20 of an inch. Do you get Friday off? So we need to know, does it snow over 1 inch in a week? So that's implying I need to add these numbers up. How much has it snowed this week? So let me write them all out. So we got 1/10 plus 1/4 plus 2/5 plus 3/20. So I'm adding these up. Remember, the first step is I need a common denominator. So I need to look at these numbers, 10, 4, 5, and 20, and figure out, is there some number that they can all go into? And the answer is 20. Okay, so 3/20 is already in 20. This one, if I multiply it by 4, it'll become 8/20. This one, if I multiply it by 5, it'll become 5/20. And this one I do times 2, and it becomes 2/20. I'm going to add these all up. So 5 plus 2 is 7. 7 plus 8 is 15. 15 plus 3 is 18/20. That's a bummer. Because remember, 1 inch, 1 whole would have been 20/20ths. So we were only 2/20ths, or if I simplify that, 1/10 away from having school off. So do we have school on Friday? Yes. Didn't get enough snow. Too bad. So remember, we had to find that common denominator, add it up, and then make sure you go back and look at what the question is. Do you get Friday off? Well, you get Friday off if it's over 1 inch. It wasn't over 1 inch, so too bad. All right, so this one I want you to hit pause, read it, work out an answer, and then hit play to see if you are correct. All right, so Megan spent 3/5 of her money on books. She spent another 2/7 of her money on new shoes. What fraction of her money did she have left over? So let's see how much she spent. So she spent 3/5 and 2/7. So let's add that up to see how much that is together. So 3/5 and 2/7. So common denominator here is 35, which is just multiplying them together. So that means this one's times 7, so it's 21. This one is times 5, so it's 10. So far she's spent 31/35 of her money has been spent. They want to know how much money did she have left over. Okay, so remember she started with a whole amount of money, 1 whole. A whole is just however many out of the same number, like 35 out of 35. So she had 35 out of 35. She spent 31 out of 35. So that leaves her with 4 out of 35 left over. So these problems can be tricky sometimes because you think, oh, they didn't tell me any actual money numbers. They didn't tell me $100 or anything like that. I have no idea how much money she has, but it actually doesn't matter because this is all about fractions. They mentioned she had 1 whole amount of money and then what fraction she spent. So then your answer is going to be in a fraction as well, okay? So we have no idea if she had $20 or $1 million. All we know is that whatever amount it was, she has 4/35 of it left. That could be a lot of money, that could be not much money at all, okay? So you don't have to have those money amounts if it's asking it with fractions and it's asking for a fraction. It's asking for what fraction, okay? All right, so same sort of thing here. Read the problem and hit play to check your answer when you're done. All right, Eliza spent 1/3 of an hour doing her math homework. She took 5/12 of an hour longer to finish her English homework. How long did it take for her to do both? So we want to know, combined, how long was it for her to do both homeworks, right? So it was 1/3 and it was 5/12. So I want to add these up. How long was it for both? So common denominator actually is pretty nice here because 3 goes into 12 if I multiply it by 4. So this becomes 4/12. This becomes 5/12. Altogether 9/12. Or if I simplified it, divide by 3, I get 3/4 of an hour. Now in this case, unlike the last problem, because it's time, and we know what 3/4 of an hour is, you could write it in actual time too, right? 3/4 of an hour or 45 minutes. But you don't necessarily have to. 3/4 of an hour is a fine answer. Either one is fine.